Inés, James, I don't think that we can hear you.
Oh, we're here?
Now we can. Now we can. Now we can hear you. Yeah.
I thought you were saying that we're going to wait a few more minutes, but we can get started if you want us.
Well, no. We waited another 60 seconds, and I think that we have mostly everyone here. We can start.
Cool.
Yeah.
All right, let's get it started. James, you want to kick it off?
Okay, so I'm James Turnbull, and we're going to talk this morning about why complexity will eat the world, and a bit about the future of software engineering, and a little bit of a potted history of where we've been. So I'm the CTO at Empatico, an educational technology startup in New York. I've written a number of technology books, and I've been an engineer for 25 years or something like that this year. And I've done a bunch of different things: startups, banks, biotech, gaming, government, primarily as a product engineer, but also as a people leader, a security person, and an operations person.
And you go by what on the Twitters?
At KARTA, Carta.
Cool, James. All right, my name is Inés Sombra. I'm a director of engineering at Fastly. I run a few of the teams there. I run the image opto, video, and load balancing products at Fastly. And this is my completely like jokesy bio. I do have a couple masters in computer science, information management. I've been an engineer for a while. And I go at random mood. I go by at random mood on Twitter. So that's a little bit of who we are.
Oh. So what's this all about? Well, as I said, we're going to talk a bit about the evolution of applications. We're going to talk about why those applications have evolved. We're going to talk a bit about the future of software engineering and the future architecture of applications, and very much tell the story of why that future is distributed. We're also going to talk a bit about why distributed computing is hard and why it is complex, and also share a bit about why we think complexity is both a boon and a cost for your software development. We're going to talk about some ways to tackle the problems of complexity and how to address the fact that software development is moving towards a more distributed state. And then we're going to finish up with a shameless plug about the conference that we both run called Velocity. And we're going to talk a little bit about how you can submit a talk to Velocity, but also more broadly to how you can submit a talk to any conference. Give you a few tips. We read a lot of conference proposals, a few thousand every year, and we have a pretty good idea of what works and what doesn't work. So, the crux of this sort of discussion is that systems have changed, and we're living now in a world where the applications that were traditional when I was first starting out in engineering, which were sort of mainframe style applications, were then succeeded by client-server applications, and then sort of more web-based applications and multi-tier applications have changed. And now we're seeing the emergence of distributed systems, of microservices, of new architectures and new patterns like serverless. And we're going to talk a bit about, Inés is going to talk a little bit about what those applications look like and what the implications are.
All right. So as James mentioned, systems have changed, and they do have changed within my lifetime in this industry. A thing that I think very important to say is that they also have changed in a way where you don't have them in a centralized manner anymore. You don't have a single computer where you have your web service process running, your database and everything within one single machine. The advent of the cloud and everything that we use actually forced us to start thinking about the composition of our applications a little bit differently. So take, for example, this sample application. In this sample application, we see some clients towards the left, the service that does a particular type of work, and it may talk to a different service for another type of work, or even just something that the service needs. And then on the right-hand side, maybe like the service that we're running or the service that we have, it takes its configuration or takes its state or data from a different configuration system, and then they all this dumps state on a database. For example, in this case, if we're talking about an application that deals with like customer preferences, my service could be the thing that talks to my clients, but then you have state saved on a database. I wasn't ready for that one, James, but yeah, let's go in. So the thing that we're trying to say in here is like now, as you can see, they're broken apart, and they're broken apart from client side, from like service configurations, and from the database side. Depending on who you are, your concerns, and then the way that your system looks is completely different, and then the constraints that you have change. Say, for example, in this case, from a client side, if you have a mobile or even somebody from your laptops, your concerns are a little bit different. Your concerns are maybe you make sure that maybe you make sure that your front end is responsive, that you can connect to the application, that you can always like have like data or have your system working even if your connectivity is poor. So that's kind of like the perspective from a client side. You care about like the interface or the UI or the presence of your service, or the thing that exposes your service to be responsive and connected, and then those are kind of the things that you care a lot about. So if we move forward to the next concern, say for example, as a distributed systems engineer, yes, good, that one. As a distributed systems engineer, we care about like the request flowing correctly. We care about like service connectivity and availability, and then the fact that your service needs to be secure. Also that you can talk to each other. So, and that also like then that you have a different type of concerns. You care about architecting your applications in a way that serves your system's goals, and those can be achieved several ways. Now, if you move to the next side. Yeah, cool. If we move to the next side, no, one before. Yeah. All right. So in this particular side, what I mean to express is like if you're, for example, a system administrator from the old days, like now we call them SREs as of a few years ago. Now the trendy term, I believe, is production engineers. So if you're one of those things, or if you feel that one of those terms applies to you, in this side of the system, you care about different things. You care that the configs are, for example, pushed to all of the things that need to consume them, that they're pushed securely, that the right keys are in the right group. You care about like the ability to predict what is going to happen. You care probably about adding potency because you want to be able to make a change and then apply this change over and over if necessary, and just like not destroy the state of the world. So those concerns are very separate than the concerns of the client side. They are very separate from the concerns of the distributed systems side, but they all are part of the same system. So, and then finally, like we have the next side, which is kind of like, for me, this represents like the traditional role of people that deal with state. So in here, you care about like that your data is fresh, that you have all of the guarantees that you need to make in terms of like data, consistency, availability, even just like scale and capacity planning are really like matter here. Or if not, if you're just using something else, you care about like the boundaries of like which state and which storage system you're using. You care about like the nuances and then like the operability of both of them. So I guess what we're trying to make with this, or the point that we're trying to make with this, next slide, please, is that we're all building distributed systems. Whether you know it or not, or depending on whether you're in, we tend to be in a specific role, right? If we're in a client or if you're a front-end engineer, you care about like something that is front-end related. If I'm a database administrator, I care about something else. But it doesn't necessarily mean that you're just like, that is your entire concern. Like, doesn't stop there. We all build applications that span different groups and span different utilizations and use cases. And this is what we're doing on a day-to-day basis. Like, we're all building distributed systems. And why is that, James?
So I really like this quote. And I think that the part that I really jumped out to me are the parts that are bolded to me, because independent entities that cooperate to solve a problem that cannot be individually solved really sums up a bunch of different layers in the process. So, for example, it sums up the architecture layer, independent architectural systems that cooperate to talk to one another. It sums up the sort of implementation layer. Systems may be in the cloud, systems may be dealing with legacy systems, some of them may be on site with you, some of them may be elsewhere. And it also deals with the people aspect of it. So it may be a different team that is responsible for the client end and another team that's responsible for the data. And so it requires a much more complex cooperation model or cooperative model in order for us to actually run and build and make these systems in a productive way. And so, like, I guess the application we showed you is a very simple one. Like, it's probably something you've seen before in your environments. And the fact that I'm calling that a very simple application, where there are 3 or 4 moving pieces, there are probably different teams that manage those. There may be different sources of data. That is an example as a toy application or a simple application. It gives you an idea of the scale of the problem and the scale of the distributed systems. If you look at the world of, say, Amazon or Netflix, Amazon is probably the poster child for distributed systems in this way. And Werner Vogels, who is the CTO at Amazon Web Services, is famous for saying that teams should build black box systems and present APIs to each other and negotiate contracts based on those APIs. And the reason he's said that is that the systems they manage, the services that make AWS, the 130 odd products that AWS distribute, are massively complex distributed systems. Netflix is another great example. They've released an entire tool set, nearly 20 or 30 tools that they use internally to manage the content and the systems that allow you to watch House of Cards every week. And those systems give you some indication of the fact that these moving pieces are starting to become universally prevalent in the systems we present out to customers.
And also their boundaries, right, James? So like these things that connect with each other, like the scope of our awareness or the scope of our understanding, it pushes us or it forces us to be concerned about the boundaries as well. So we have our own thing that we're running, but in the context of an Amazon or like the context of an Netflix, or even like in our own applications, we need to understand the context that we're in. So.
Yeah, and particularly with regard to, and those boundaries are, again, multi-tiered. So they're data boundaries, they're service boundaries, they're security boundaries, they're people boundaries, in a way where previously, you no longer own an application, you own a segment or possibly even a slice of an application or a service, or even some aspect of that service, in a way that previously you had a much clearer understanding of the whole context of your environment or the whole interaction. You can no longer maintain that state in your brain, and hence these systems are complex. So what does this mean? Well, we understand that they're hard to build. You inherently requires collaboration across those boundaries. It inherently requires collaboration between entities. They're hard to reason about, and where I said before, you previously understood a lot of the context or a lot of the scope of your applications. Now it requires you to have to even accept that you will never be able to hold a full picture in your head of how data necessarily flows through one of your systems, and that's simply a human failing of the fact that it's almost impossible to maintain an understanding of the relationship between, say, 20 or 30 different entities, with different data models and different services and different pieces. As a result, incredibly hard to test. End-to-end testing is something that was already a challenge in, say, a 3-tier web application. Generating a request as if the customer had seen it all the way through the experience in the back end of it was already a hard problem. In the distributed systems world, it's very hard to model the behavior of that system in such a way that you can mock or test it. And by extension, it's super hard to troubleshoot. It requires you to collaborate with large groups of people, not necessarily people who work for the same organization as you, in order to have a conversation about how to troubleshoot it. It requires you to understand how data flows through a variety of different systems, how it may be changed, potentially systems that are black boxes to you, where you can't open them up and peer on what happens inside. This has serious implications for security. Not only is security a troubling problem in environments where you have to be collaborative, but now you are maintaining infrastructure for multiple components. So one component may be secure, but you aren't able to secure another. You may control the security of one component or another, and you may not even control the transitions between security zones. Speaking as someone who spent a long time operating systems like this, they require a whole different skill set. You can no longer do things in a manual way. You can no longer do things relying on checklists or instructions. You have to supplement that with significant automation, and you have to supplement that with a significant orchestration. And then you have to build teams that are capable of understanding all of those components and capable of directing them and maintaining them. And those teams not only inherently have to be very collaborative, and obviously in the operations space, you know, we've seen terms like DevOps emerge in the last few years, which is collaboration between developers and operations people. But SRE people are much more structured around being able to manage complex systems rather than simple ones. And systems engineers and front-end engineers now need to understand concerns that they previously didn't need to care about. And then someone over the top needs to have a picture of the architecture of the application in such a way that they're able to make good technical decisions, good resourcing decisions, and good collective decisions about the life and about the development and performance of those applications. Inés, do you have anything to add there?
Yeah, I do. And even you have to do this while everything that you have changes from day to day. So like your entire mental model of a system may be applied today and may be completely different tomorrow because you don't control the microservices that you're like the ins and outs of everything that your system connects to. I think that's a really like the seminal quote to describe why distributed systems are hard comes from Leslie Lamport, who is like one of the fathers of this industry. And then he says that a distributed systems is a distributed systems is something where like a computer that you didn't know existed or a system that you didn't know existed can bring your own system down. So if we move to the next slide, the reason also that they're hard is because of two main things. It's because of they have to deal with asynchrony and partial failure. Asynchrony means that since we have this multiple interconnected pieces cooperating together, you don't have any control about the messages that they send to each other and what could happen to those messages, but you're affected by it. You don't have any control about the clock drift of something that, for example, that your system connects to or like talks to. I may think that it's today at 10:20 a.m. in San Francisco, and in James' computer, he could say that it's Friday at noon in New York City, and I have no idea what time it is in New York City now. Is it noon right now, James?
No, 1:20 p.m.
Cool. So at that point, my understanding of James's like computer clock and my computer clock is different, and I can't do anything about it other than just do this mechanism of asking James what time he thinks it is. But also, let's imagine that that answer that James gave me got lost. I wouldn't necessarily know like what happened or what time it is over there, or like even if James is saying this podcast or not. That's what we mean with partial failure. Anything that has to do with components and their communications, we don't get to control, but we suffer from it. And anything else that has to do with time, we can make any sort of assumptions because we don't control that. So time is really hard.
So all of this stuff, you know, we've talked a bit about the technology, and we've talked a bit about the changes in the way applications are structured. But I think it's important to also look at the other driver here, which is something we often don't consider in our world, is that the business is actually what's driving a lot of this change. It's not just you know, technology for technology's sake. And so it now really matters that we get these sort of complex tools right. And the reason that I feel that it's changed significantly in recent years is that, to me, technology is no longer a cost center in businesses. It's now a revenue center. Companies cannot do business without technology. They cannot do business without presenting a technological interface to their end users. There are very few companies in the world now, certainly in the first world, that can function without email. If you consider email the base building block of, say, a business's communications needs, then their customer CRM might be the next layer, or their service system, or their general ledger, or their accounts payable or accounts receivable systems, right up to the interfaces they present to their customers to provide, you know, the ability to order something or buy something. If those systems are not functional, businesses stop. It is no longer a case of there is a manual failover, or there is we can fax an order in. If Amazon's front page goes down and you are unable to buy products, Amazon essentially goes out of business or shuts down for that period. The other reason it matters, right, is that we are living in a world where businesses and companies no longer buy technology in blocks. Not every technology organization builds all of their own applications. Not all technology applications even operate all of their own applications. we rely on fragmented service offerings. For example, I've talked about Amazon a couple of times and Amazon Web Services. A traditional model in a lot of startups certainly is that a company would be hosting their infrastructure, say Amazon Web Services or Google Cloud, and then another company may be providing some security support, another company may be providing operational support. There may be some in-house developers who are supplemented by outsourced developers or contract developers. There may be a product or a customer team that supports that. And there may be a number of other sort of services they consume, for example, monitoring or metrics or data storage or performance testing, APM tools like New Relic, for example. All of those tools operating together, all of them necessarily outside of your control, and all of them hard to get context on, means that not only that makes complexity for applications, but makes complexity for the sort of business and the buying and the operating of systems. And this is only going to get worse. As more and more companies, as I said, there are very few companies left that aren't already focused on technology being their sole line of business delivery method or delivery platform. But more and more systems will head that way. Customers have an expectation, particularly younger customers, millennial customers, if you want to use the cliche, they have an expectation that services will be available to them instantaneously and that it will be available to them on their phones, directly to them in real time. If you look at large financial institutions, for example, they are slowly getting their heads around the fact that you can no longer do payments transfers that take multiple days or even multiple hours. You can no longer rely on paper-based systems because customers simply will not put up with it anymore. And they will go to find alternate vendors who provide services in that way. So because of all of these reasons, we are stuck with this distributed future and we need to be able to understand and deal with it.
Cool. So as James mentioned, we live in a new world, right? Like the lessons and practices that we learned when we were trying to construct like 3-tier web apps are no longer sufficient. And we have to start thinking in broader terms, and then we have to just get comfortable with the idea that some of these things are hard and they're complex. And these complex systems definitely force us to need new paradigms. So what we used to do won't work with the new world. And even as James mentioned with his previous example, if you relied on, or if you force your customers to have a 3-day waiting period to transfer some cash, when these days we can just like send our friends something very quickly on the spot with something like Venmo, like force us as applications or systems engineers to face this new complexity or this complexity head on. So we don't get a chance, so we don't get a choice anymore. So if that hasn't really depressed you, let's hear what are the things that we do want from our systems today. What are the constraints or the things that we need to provide?
So some of these may appear to be sort of cliches and things that you've already cared, like, systems need to be fast, robust, and available. The scale by which that is true is significantly different. Customers now, as I talked about, are expecting real-time interactions with the systems they use, and they're expecting instantaneous results. A significant number of studies by companies like Amazon that have significant retail web presence have indicated that even small dips in performance at the front end or in the responsiveness of transactions as a whole result in customer drop-off and result in significant loss of sales. So abandoned carts are significantly higher if a customer does not feel the application they're using is responsive. And this applies to pretty much everything we're building these days. So the idea that sort of fast was required always, now we need to be super fast, and our customers are very highly conscious and aware of that. And as a result, robust and available. Customers no longer expect systems only to be operational during business hours. They have a 24/7, often global expectation that systems will be available, they'll be robust, and they won't break. We've seen significant outages in large numbers of sort of institutional organizations in the last few years. Europe and Australia, the UK and the US, for example, have seen significant ATM outages, for example, or significant electronic funds transfers or electronic payments outages that have resulted in significant customer unrest. Systems are made of interconnected pieces, as we discussed, and they're also not integrated with, we're not integrating with systems that we entirely control anymore, as we sort of covered in the past. And you don't always understand or control every facet of every system. Inés.
A funny story, but it doesn't necessarily tie in with everything you said, but it's applicable. So I work at a company that does internet infrastructure, and there's something that I learned when I joined, is that apparently, like, you have oceans and you have big wires where your data goes through. Sometimes, like, the pulses that the wires make cause shark to come and bite on your cables, or bite on the cables that feed the internet. That causes applications to stop working, or causes the internet itself to have to self-heal. And in a way, you really can't plan for, like, sharks eating your wires, but it does make the point, or it highlights things, as James mentioned, that our applications at least need to understand. Or maybe, like, we don't have to understand, but our network providers or our service providers definitely do. So if we can go to the next slide, this is a really terrible segue to that, but I really kind of like that story because I didn't know that it was possible that a shark could come and then just, like, have an effect on the latency or the ability of your customers to get to your data very fast. I don't know. I had to share that one because it was interesting for me. All right, so what we've seen is, like, things are hard, everything is terrible, everything is going to be harder, and we have to make sure that we continue with business as usual. So as engineers, what can we do when everything that we've learned in the past falls short? What helps us build better systems? All right, so the only answer that we can give you, since the book is being written at the moment on how we construct these applications, is industry collaboration and sharing. So, like, via the people that are doing this, or via other peers or other practitioners that are dealing with the same problems that you're dealing, like, you converge, or new best practices and new paradigms are starting to get formed, right? We are creating the way that things ought to be built together, and then we're creating it daily with the challenges and then the patterns that we put together or we encode in our applications. This thing of bridging worlds and knowledge sharing is extremely critical, because in order for us to have something that is operable and secure, and even just, like, performant, like, those things cannot be bolted on top anymore. They have to be, you have to construct an application from the ground up with these concepts or, like, these concerns in mind. And also, when we share our challenges and solutions, we do make the whole industry better. And we help the state of the industry evolve towards more reliable applications, more secure applications, and things that are also, like, more observable. So let's get to the next slide, James.
I was going to add a couple of quick things.
Yeah, do it.
So I think the really interesting thing, point about that Inés hit on, is that a lot of this stuff is not codified. A lot of this stuff is happening very quickly. People are encountering problems at particular scales that we've never encountered before. You know, the scale of like, we had 100,000 users, now we have 1 million users, now we have 10 million users, now we have 100 million users, is something that means that we are turning over new rocks in systems architecture and system patterns all the time. And I think it's really important that we also understand that the future is not evenly distributed. There are some companies that are moving ahead of us and some companies that are behind us, and so it's important to be able to find those companies that are slightly ahead of us in the race, find out what they discovered and what went wrong for them, extract that knowledge, or adopt the tools, or learn the lessons they had in order to actually make sure that we are more successful further down the line.
Yeah, which brings us to Velocity, and then Velocity is the conference that James and I are a part of, and this is what we try to do. Exactly what James mentions. We're trying to ensure that we can bring these lessons and what people are doing in the field back to back to practitioners. It's like, unless you live in San Francisco and can go to the bar and then just have a conversation with somebody that you know, the patterns that are emerging may not necessarily be evident to you until way later in the game, and then maybe you need them today. So for those of you who are not familiar with velocity, James is going to tell us what it is.
So the conference started in 2008, and it was started by Jesse Robbins, who was at the time head of, I guess, what was effectively at the time sort of the responsible for testing and disaster recovery and operations for Amazon Web Services and Amazon as a whole. And Steve Souders, who's very well known at Google and Yahoo and a number of other places as being a JavaScript performance engineer. And was originally focused on web operations and performance. And it was timely because 2008 was about the same time that we started to see some things like DevOps appear, where people were talking about collaboration between developers and operators and developers and sysadmins. And the goal was to break down those silos. And the key thing the conference posited was that performance matters for customer success. And as I talked about earlier, responsiveness and readiness and the ability for your users to get a real-time instantaneous response guarantees that you will improve sales and improve throughput of your systems. So what did it achieve? It built a new community around best practices. And I think probably the example I use to people here all the time, and this is a presentation that's still worth watching, is John Allspore, who was at the time at Flickr, and Paul Hammond, who was also there, talked about how they changed deployment. And traditionally, in a lot of organizations, deployment is a problem that means that it's hard to get new code out in front of customers. And some companies may only deploy once a quarter, once a month, or once a week. John and Paul discussed a paradigm where essentially where new commits, new changes to the environment were being pushed out instantaneously. And this sort of was the start, really, of the continuous deployment, continuous delivery sort of model.
Yeah, and I have one thought there. And the reason that they did it, or the reason that they were able to do, it changed the way we thought about our sets of changes. Because instead of doing something that collected and assembled and just combined very large features, they shifted our paradigm, or they shifted our thinking into, instead of like making massive deploys, making very tiny deploys. And when you have something where your area of change is that much smaller, it allows you to just like roll it out and release it quicker. So that was something that didn't exist before, or that change of thinking wasn't very typical.
And it also did spawn a number of companies and tools. I can sort of pinpoint a significant number of tools in the environment, including inspiring things like Docker and containerization and microservices, companies like Chef in the configuration management space and Fastly in the CDN world, which had adopted these new paradigms wholesale as a way of providing services and technology to customers.
I also work for Fastly, so in some ways Velocity created my job, so that's pretty cool. So we said everything that has happened with Velocity in the past. In the 10 years that the conference has been running, it managed to do a lot, but this year we decided to change it, and we decided to go back, look into ourselves, and just change as much as we could of the tone and then the messages to reflect like the new world that we live in. Right, so the things that we ended up changing are like we went, instead of from like focusing just only on the development side or the DevOps side and the front-end performance side, to embrace a whole like systems thinking approach. So we want to just like go from anything that has to do with the end user, as you saw in the first example, like anything from your client to like your storage layer, especially the seams, and then now. We're trying to make sure that these engineering practices that are evolving for distributed systems and respond to these complexities brought to you within our program. And also we want to look at what it takes from an organizational perspective to enable your company to do that. So as a leader or as a manager, when there's so much complexity and there's so many unknowns in the world, what can you do to make sure that your teams can respond to this like appropriately, and then they can react fast, and then they continue to be high performant?
So why attend and what can you learn? Well, I think at one level there is new architecture and patterns. There's definitely we have a strong sense across the conference of trying to introduce to people to new models of the way of doing things and new patterns that they can adopt and understanding the risks and implications of those patterns. So, for example, talking velocity in the last few years have been people on the very early stages of serverless and the very early stages of microservices. And there's a very strong, for example, adoption of things like containers and also some of the theory behind monitoring complex applications. We also talk a lot about tools and techniques. So we try and gather people from who are at sort of the cutting edge of this, the bleeding edge of this, who are doing things at scale that will probably impact you in the next 12 to 18 months, from companies like Netflix or Twitter or at Google. And we have a community of folks who are able to say, you know, we built this tool, or we adopted this tool, or we adapted this tool, and this is how we use it. We also run tracks that are the full stack. So we look at things like the data center and network and CDNs and content, all the way up through the stack to the end user and end user performance on the browser, as well as wrapping that entirely, as Inés said, with leadership and growth discussions. We have an entire track that is dedicated simply to how do you manage the engineers and your environments and your people inside these really complex environments.
Cool, yes. So this is us this week, earlier this week in New York City. As you can see, we're having a blast on stage. And yeah, so if you are like close to London, we are going to be there next week. No, yes, next week. And you could come and check the things that we mentioned, and then check the program, and then see we really want to make our talks educational, and also like the tied to real world examples and real world problems. So we've tried very hard to curate a program and then just to bring you keynoters and speakers that will be able to give you this type of lessons that we just mentioned. And yeah.
Sorry, Inés, you go.
No, that's good.
So this is some of the people that we're really excited about for Velocity in London. We have Sarah Jane Dunn from Microsoft talk about biological computing, Baron Swartz, who's a fairly famous figure in the database and back-end performance world, talking about quantifying scalability and helping you understand how to how to measure the implications of your scalability. We're starting to look very closely at things like blockchain, and particularly around the trust models for blockchain, which have potentially are a significant path towards understanding how to build distributed trust models. And carry on what can go wrong with the distributed systems. Anne has a long history in the distributed systems space, and as she describes it, she has broken every single system you've probably ever seen. Sam Newman is talking about serverless architecture, which is probably one of the next waves of implementation models for distributed systems, is really looking at sort of serverless technologies like AWS's Lambda product. And Angie Jones from Twitter is going to talk about continuous integration testing. Twitter is this is probably the first time Twitter has probably opened the curtain on what they do for continuous integration. They deploy a number of systems in a fairly complex sort of way, and I think some of the lessons they have to offer are super interesting.
Yeah, and we also want your voice. As we mentioned, we are all together, right, in the way the applications are going to happen. And then the challenges, for example, that you would have at a company like Twitter are not the same challenges that you would have at a company like of your size. So there's a lot of uniqueness, and there's a lot of room for innovation, because nothing is we're no longer in a way where we can be prescriptive, right? There's no longer a cookbook on how you build applications per se, but like it all depends. It's all about the trade-offs that we make, and it's all about the choices that we make in that particular situation that we're in. So we want to hear from you. We are always looking for new ideas and insights. The CFPs for our next year velocities, we tend to do them in 3 locations. We do them in San Jose, New York City, and London. So we're going to be opening those CFPs very soon. And we would really like to hear from you, and we would really like to see more submissions. So what do we want to do in order to get accepted, James?
So I think this is really, and this is advice that really extends beyond Velocity into sort of any conference you apply for. Yeah. And as I said earlier, we review literally thousands of conference proposals every year. The first thing I would say is write what you know, what you've learned, or what is challenging you. Obviously, if you can sometimes think to yourself, I'm not from a company like Twitter, I'm not doing anything cool. But often you're adopting a new tool or a new technique or a new architecture in an environment that may be very different, that may be a traditional enterprise organization, or in an outsourced or remote distributed environment. And the lessons you are learning may be valuable to a lot of other people out in the community who are also looking at things like Twitter and going, how do I exactly adapt that, like where you look more like Capital One than Twitter, for example.
Also, nobody is Twitter other than Twitter. The problems that Twitter have only apply to Twitter. So I think in a way, it shouldn't deter you from submitting, because maybe your challenges are completely different, and maybe what Twitter is doing works for them but wouldn't necessarily work for you, and maybe your model matches somebody else. So there's only one Twitter, and in some ways it's like the experiences that you have and the things that you've seen are valuable, and we wanna know.
Yeah, and we love real life stories and experiences, case studies, real examples, things that have gone wrong, war stories. We're extremely, our audience and us are extremely attracted to those. You can learn incredibly important lessons by somebody telling you what they did and what they went through and how they solved the problem. Yeah,
so the way that you get out of a hole is like exactly what we want to know. We want to know how you reasoned about it, what are the things that you put in place, and also like that translates normally into lessons that others will learn from.
And I think it's important also, like, these are more sort of operational aspects to submitting to a CFP. Don't write us an essay or a paper. Write something that is long enough to explain what you intend to say and what the community will get out of that, but not so long that a reviewer who has to review hundreds of proposals will go, too long, didn't read.
Yeah. Also, not super short where it's like, I'm going to talk about computers, because that tells us nothing of what you're trying to say. So it goes both ways. Not too long, not too short as well.
And spelling, grammar, and clear prose matter. Like your description of the talk is what's going to end up in the program of the conference. And that's something that if you want to present to the world, you want to make sure is spelt and has the right grammar and clearly prose. And we're looking for people. It also gives us an indication of whether you're a good communicator.
And we really don't want talks that are use my product. We were interested in the educational aspects of like reasoning and thinking through a problem-solving situation. So just please don't pitch us a product. Don't be like, use my application X to solve all your problems, because also we're not even going to believe the premise. Because as we try to explain to you before, things are incredibly complex and nuanced and come with a whole lot of trade-offs. So we're not interested too much in marketing pitches, but we are interested in your real-life stories and your experiences and what you've learned from them.
For example, we get a lot of feedback from vendors like, well, if we can't market our product, how do we tell our story? And if you do work at a vendor, then find some of your customers who love your product. Find some of your customers who have adopted your product and have those real-world experiences of your product, and get them to talk about that experience. That's not a marketing pitch. That's an actual, like, that's something that communicates to us that, they use this product in the context of this environment, and it was useful in this sort of way. That gets the message across, but without being marketing pitchy.
Yeah, or if you have a product and you've learned lessons while building it, and then you want to talk about your constraints, the things that you've done, what the assumptions that you had when you were building it. Like for example, I have a product, so I talk about it within the context of the lessons we learned and where we get it right and where we get it wrong, and then the things that we need to fix, the parts or the areas where we got it wrong. So that's a good way to talk about the things that you're building.
Okay, thank you so much for your time this afternoon, or we're not sure what the time zone is where you all are, but thank you so much for that. Really importantly, we can't sort of leave without saying that we can save you some money on the conference too. So the code APP25 gets you 25% off registration for Velocity London. We make similar discounts available, particularly for all of the other events, but this one is we'll get gold and silver, bronze passes, 25% off those for the conference in London in a week or so. But we'd love to see you all there. We think it's a really great event, and I think that feedback in our community in our community indicates that a lot of people walk away with significantly good lessons of what they learned. It's a great place to meet people. It's a great place if you're looking for a job or want to change a job.
Yeah.
We have a huge community of folks who are. I literally think last time I asked who's recruiting, 1,000 people put their hands up.
Yes.
So, if you're looking for a job, it's a great place to go to.
Yeah. So come see us in London next week.
Great, James, Inés, it was, wow, it's such a wonderful presentation. Can we do some questions in the time that we have left?
Sure.
Charlie.
Okay, perfect. So first of all, I'm going to take this opportunity and say that the information that you have on the slide here, I also put it in the chat box. So I think all the audience should have access to the link and to the discount code. So you definitely check that out. And I also wanted to say that I personally attended Velocity San Jose this year, and other people from Applitools attended Velocity in New York City, and it was just an absolutely amazing event. So worthwhile checking and attending. Really, really wonderful. And regarding, yeah, amazing, and definitely, and I can't attest for the other speakers, but I saw that Angie Jones is speaking in London, and she is absolutely fabulous, and anyone that can catch her talk should definitely do that. She is an amazing speaker, and just so knowledgeable and interesting. So definitely worth checking out. Regarding Velocity, just two more questions. First of all, where can people submit if they want to? I didn't see a link there, or maybe I missed it. Where can they submit the talks or their talks or ideas? Where do you publish it?
Yeah. So in the CFP for next year has not yet opened, but in December is coming up. So in December, the moment that you go to the site, you would have a very, very obvious link to submit a proposal. So that's coming up in December, and that would be, the first one would be for San Jose. But you can submit to the CFPs of London and New York City like shortly after.
Okay, so that opens in December, and when does it end? Do you know?
I think January, maybe?
Yeah, it's open for a bit over a month. We tend to give people a good long time because we know that most of you will submit in the last day. But yeah, we leave it open for about a month.
And then after the CFP gets submitted, we work with we have a program chair. We have a program. What's the word that I'm using?
Committee.
Program committee. Yes, our wonderful program committee goes through all of the submissions. We assemble a program committee that speaks to the many perspectives on engineering. So like if you go back to that application that I showed you, we try to put people in the program committee from like the front end side, from the systems operation side, from like system administration and security. So we try to assemble a diverse enough program committee to make sure that the talks are seen by people that they would speak to like different audiences. So that's what happens after.
Okay, so definitely in December, go to velocityconf.com and you will see the call for paper link in there. Is that true? Yes? No?
Yep, that's correct.
Okay. That's correct. Okay. Another question that I have here about Velocity, and then we'll go into questions about the presentation. And so I just want to remind everyone, you can still ask questions about the presentation. Well, I'll take just one more question about Velocity. Someone asked that, I don't know, maybe it was like that in the past, but maybe you can clear up any misconceptions now. He said that talks were by invite only, and you weren't able to submit a call for paper or anything. Is that something that has changed, or are calls or is this now open for everyone?
So we do a combination. So we have a CFP. So we source talks from the CFP. If something really great comes from the CFP or something that we really like, we look at both things. So we use the CFP a lot to source the conference, and then we may do invited talks to round up the themes that we're trying to tell within the event. James, you have something to add?
Yeah. So the conference very early on, probably more than 8 years ago, was sort of the talks were more invited than CFP. For the last 8 years, though, probably 75 to 80% of the talks are people that have submitted a CFP talk. So it's our way to find new speakers and new voices in the community. But for example, if we want to really talk about serverless and we can't find somebody to talk about a particular, say, monitoring serverless, we may reach out to someone in the community and say, are you prepared to share your thoughts and ideas about this?
Yeah. And we totally do. All of the keynotes are invited, though, so that we personally curate.
Yes, keynotes are different.
All right, thank you so much for clearing that up. And now we do have a question about the presentation. Here goes. How can SE help in dealing with complexity of distributed systems?
Software engineering? SE, you mean by software engineering, right?
I hope so. I didn't ask it, but I hope so.
So I guess for me, the way that I would think of this question is like, if we're talking about software engineering in general, it's a big practice. So the way that we deal with complexity is by not having a unified way. Like you have to do many areas of concern, many different techniques. There's never really going to be a quick and just like a quick answer other than it depends. So I think it depends is the thing that is going to hold true. It depends on what you're trying to do. It depends on your constraints. It depends on the things that in your systems go. So unfortunately, like dealing with complexity is problematic, or it's not really difficult. And also, I think that what I want, there's also another point that I wanted to make. Not all complexity is bad. There are some things that you can do in your system that increase complexity, but also like affords like better, for example, operability. And in that context, complexity is great. Complex is like completely appropriate. But well, converging into an answer would be that there is no single, like there's no silver bullet. You have to think about a lot of things. You have to think about a lot of context, and software engineering as a practice has different venues for this. Like, I mean, you don't have a single track for software engineering. You have things that are systems engineering. You have things that are like storage systems. So you have to know a little bit of everything, or at least you have to be aware of when you're reaching a boundary, and that actually helps you at least understand where to go look for the next answer when you're presented with a problem. Hopefully that answers the question.
Yeah, to me, that key thing is that you can't necessarily know what the pattern that will solve this problem is, but you need to be aware that there is a boundary and there is a pattern. Yeah. Like it's when you sit in your own silo and you don't look outside to see what the implications of your changes are that you start to run into problems. I think the really important thing is being aware that you are part of a system and part of a team, and that certain things you do will have broader implications, and you need to go and have a conversation or articulate what those changes will be, or share a new architecture. Without that, you start to run into problems almost immediately.
And also, there's tremendous amounts of research in the computer science world, because some of these problems of distributions and how you offer guarantees of things that talk to each other have already been studied and published in academic papers. So if you have a habit of at least just doing a search and go back and see what the literature could teach you, it may be that the problem that you're trying to solve is impossible to solve. So it's very handy to know that. So you either reword the problem, or you just reformulate the problem, or sometimes you even get somebody whose life research got dedicated to solving this problem for you. And now that is a pattern that we're starting to see with applications, where, for example, in academia, you talked about gossip protocols as a way to disseminate information reliably and now you start seeing more applications and more systems that get constructed using this area of research, or using the things that we've learned in academia. So we're starting to see these two things where we're starting to combine the lessons we learn in university and the research that continues to happen there to the problems that we have in industry. So that's also another thing that has been very, very interesting to see.
Okay, James, unless you have anything else to add to that, I think that that we are just running out of time for today, unfortunately. So again, I want to thank everyone that took the time and joined us for this live session. Of course, I want to thank you, Inés and James, for taking the time and giving this very in-depth and insightful session. I think that we were very lucky to have you here with us today for this session. So thank you, and I hope to see you all at our next event.
Thank
Thank
you.
you.